Hello and welcome to another video, this time taking you through Mechanics 2020 question 3, which happens to be a variable acceleration question. So let's have a look at it. Now you might wonder straight away how I know it's a variable acceleration question. Well, it's simply in looking at that definition of acceleration. This acceleration depends on the time, and so it's changing according to the time, and therefore the acceleration is varying. So I know in these questions I always need to do S, V and A. You differentiate going down with respect to t, and you integrate going up with respect to t. And that's really all you need to do these questions. That and just knowledge of how vectors works, which is important knowledge, and that you kind of get sometimes when you're doing the constant acceleration questions and things like that. Anyway, okay, let's have a go at it. So here's its acceleration. We know when t equals 0 the velocity is 36, so yeah, and it's 36 0 by the look of this, and so we've got to find the velocity when t is 4. So go from acceleration to velocity, we need to integrate, and so we've got I'm just going to write it in a more convenient format: 1 minus 4t and 3 minus t squared. Write it in column vectors, it's always easier if you ask me. That's going to give us t minus 2t squared plus c1 and 3t minus t cubed over 3 plus c2 for our velocity vector. Now, there's lots of marks available for this, which is nice. Okay, now we do need to find c1 and c2, but we can find that because at t equals 0, v equals 36 0. Oh. And so can you see here, t is 0, that's going to give me 0 0, that's going to give me 0 0. You can say by inspection then that c1 is 36 and c2 is going to be equal to 0. Okay, that's our constants worked out. So now we know that the velocity vector is in fact t minus 2t squared plus 36 and 3t minus t cubed over 3, and that's it. Yeah. Now we need to find the velocity when t equals 4, and we can see that the velocity vector then is going to be, okay, 4 squared is 16, that's 32, so we've got 4 minus 32, which is minus 28, and then we're adding 36, which is 8, and here we've got 4 times 3 is 12. 12 minus 64 over 3, well 63 over 3 is 21, so that's going to be 21 and a third. So 12 minus 21 and a third, that's going to be the same as, let me just have a little think, minus 9 and 2/3. I think minus 9 and a third. Obviously you can do that, it's actually minus 28 over 3, but obviously you can do that on a calculator if you want. But yeah, that's right, because you've got, essentially you've got 12, which is 36 over 3, minus 64 over 3, and that comes to minus 28 over 3, doesn't it? Yeah, it does. Okay, so there we go. That's the first bit. Sorry, I was just checking my arithmetic there, because I didn't go near the calculator. Okay, B. Find the value of t at the instant when p is moving in a direction perpendicular to I. Yeah, now it's velocity which tells you direction of motion. Yeah, velocity always tells you direction of motion, and we want it to be perpendicular to I. So the velocity vector, which is t minus 2t squared plus 36, well, this vector is going straight up. Now it will be going sorry about my terrible handwriting. It will be going straight up when the when the j component is 0. Yeah, so j component must be 0 because it's going directly straight up, it's going parallel to I. And so we're going to get 3t minus t cubed over 3 equals 0. So 3t, well 9t is t cubed, and so ignoring t equals 0 we get t equals 3. Oh, sorry, perpendicular to I. Caught me out. I was reading this as parallel to I. You see, I'm just like everybody else. I rush through questions, I don't read them carefully. I read that as parallel, but it is in fact perpendicular. So that would have been the answer, t equals 3, if it was going parallel to I. But it's perpendicular to I. Ah, you swines. I wish they put that in bold. But, you know, I've got no excuses. I just didn't read the question carefully enough. So if it's going perpendicular to I, well, that means it's going parallel to J, which means I should have equated the other one equal to 0. God, that's such a stitch up, that one, isn't it? I feel like that's a real stitch up. But it's why we check our answers, isn't it? It's why we check our answers. So if it's parallel to J, then the I component equals 0. And so t minus 2t squared plus 36 equals 0. And so that's going to give you 2t, well, firstly I'll change it to 2t squared minus t minus 36 equals 0. I'll probably use a calculator, but you don't have to, because they do recognise, well, I'm totally fair play to you if you want to use a calculator here. T plus 4, that gives you minus 9t plus 8t, so that's minus t. So you're going to get t is 9 over 2 here, and that's the time when it's going perpendicular to the vector I. Watch out for that. Ooh. Okay, part 2. At time t seconds, where t is greater than or equal to 0, a particle q moves at its position vector r meters relative to an origin is given by r equals t squared minus t for the I component and 3t for the j component. Find the value of t at the instant when the speed of q is 5. So firstly, I guess we'd better find the velocity. Yeah, and if you look here, to go from displacement to velocity, we need to differentiate. And this is displacement. They didn't call it s, but r is position vector, so it's position vector or displacement. So if we differentiate this to find v, we're going to get 2t minus 1 and 3. Yeah. Now we know that the length of this vector, because speed is the length of the velocity vector, so the length of the vector is going to be equal to the square root of 2t minus 1 squared plus 3 squared, and that should equal 5. Well, we just got to rearrange this now to find the value of t. So I'm going to square both sides, and I'm not going to square out the brackets actually, because I don't think it's the easiest way of doing it. So 2t minus 1 is 16 all squared. Square root it, you get 2t minus 1 is 4 or minus 4. I think we're only going to be interested in positive 4. Add 1 divided by 2, you get t is 2.5 seconds. And there you go. That's all there is to it. Okay, hope you found that video useful. Apologies for the blunder I almost made with parallel and perpendicular. It's, you know, distinguish those words, but it comes with reading questions too fast and rushing, yeah? So just make sure you check your answers. Okay, bye-bye. Keep up the good work.